Okay, so here we are, 3.4. This is the last section for volume, or pardon me, the last section for chapter 3. It's called volume, and volume is space that occupies a 3D shape. So just to reiterate what we're talking about here, okay, a straight line is one dimension. Okay, that's a straight line. It is one dimension. If you cross straight lines at a right angle, or basically, in fact, any angle, but you gotta close off the lines, what you create is two-dimensional space. Two-dimensional space, we fill it in, we can call that area. And then, of course, if you want to connect two-dimensional figures, so let me just finish this off. If you connect two-dimensional figures, you can get 3D shapes. Okay, and then here we are just connecting the edges. And then, okay, the space that's in there, we call the volume. So volume, area, and this is length. So there are a set of formula that you're going to use for volume. There's a set of formula that you're going to use for area. And then length is various units like feet, inches, centimeters, meters, etc. So you're more than welcome to read example 1. I'll do the build your skills. The first example is a fish tank, which is rectangular prism. Okay, 30 by 24 by 18. So 30 by 24 by 18. And these are all in inches. So when you multiply all those things, you'll get the volume. Okay, the volume formula is just length times width times height. So 30 times 24 times 18. And since they're all inches, inch times inch, you get inch to the power 3, which we call cubic inch. And we write it like that. So that's a cubic inch. Now basically what you're thinking about is an inch that way, an inch this way, and then an inch into the page. And these are called 1-inch cubes. And basically what this example is saying is we have 12,960 of these inch cubes, and that would be the space inside this object. If you want cubic feet, you're going to have to convert these to feet first. That's the easiest way to do this. So we know there's 12 inches in every foot. So let's convert one of them. 30 inches is x feet. Cross multiply, you see that you end up having to do 30 divided by 12, which is 2.5 feet. So 2.5 feet by the 24, that's 2 feet. And the 18, that's 1.5 feet. So 2.5 times 2 times 1.5 for your volume formula for length times width times height. And I'm getting 7.5 cubic feet. Now a cubic foot would be a little bit different than an inch, cubic inch. So you'd have a foot wide, a foot length, make your square for that, and then you'd have a foot into the page, and basically you'd have this 3D shape that's a foot by a foot by a foot, much larger than an inch by inch by inch. So you'd have 7.5 of these large cubes to fit the fish tank. Okay, next one is stacking boxes. What is the volume of each box? So same idea, volume is length times width times height. 3 by 2.5, I'll just use a decimal, times 1.5. These are all in feet, so this is all same question. 3 times 2.5 times 1.5, same formula, I mean. That is 11.25 cubic feet. And again, it's important in this section to write the proper unit. Okay, so it's feet for the linear measurements and cubic feet for the volume measurement. Then it says, will the contents of a box that is 3 inches by 4 inches by 6 inches fit into a cube with size of 4 inches? Okay, so let's draw the first one, 3 by 4. So this is going to be a rectangular prism because 4 is different than 3. And then it would say it's 6 inches into the page. And we just draw them at an angle. So that's 6 inches that way. So 3 by 4 by 6. Let's multiply those. 3 inches times 4 inches times 6 inches. And we get, I think that's 72. 72 cubic inch. Now let's do the square. Pardon me, the cube. Now the cube will be 4 on each dimension. So 4, 4, and 4. So the volume, same formula, length times width times height. 4 times 4 times 4. And that is 64 inches cube. So will the contents of a box, that's this, fit inside the cube? The answer is no, because this number's too big for that number right there. Okay, example 2, you can read, it's probably just volume and cost. So these are probably similar, so let's just do 4, 5, and 6. It says a garden bed is 4 foot by 3 feet and has a 6-inch layer of soil. And it says a bag of soil contains 2 cubic feet of soil. How many bags are needed to cover the garden? So imagine this rectangular bed, and you gotta draw it at an angle. That was bad. Use the line tool. You gotta draw it at an angle to give the observer the idea of perspective. So it's only about 6 inches. Oh my gosh. It's only about 6 inches deep, so just a tiny little line going down. And close it off. So there's the garden. Like I said, it's 4 feet by 3 feet. And then it's 6 inches deep. So the up down is 6 inches. Into the page is 3 feet, and length or width, whatever you want to call it, 4 feet. So to get the volume of that, all you do is length times width times height. They have to be the same unit, so 4 feet times 3 feet times 6 inches. We're going to have to convert that to feet. So 6 inches is half a foot. So 4 times 3, 12, times a half is 6 cubic feet. That's the volume of soil that you would need for this garden. So you'd have to layer this up with soil, just dump it in the little box. And then it says that a bag contains 2 cubic feet of soil. So you would need 3 bags, since one bag does 2 feet. Okay. Now there's a couple things you might need help with, like this conversion and this proportion. Are all things you should already know. So let me just review them quickly. 12 inches equals 1 foot. We had 6 inches, so it would go there, and this would be x feet. Cross multiply 1 times 6 divided by 12. That would give you half a foot. And then for the proportion, I'll do it on the left here. It says 1 bag equals 2 cubic feet. We have 6 cubic feet, so x bag over here, and then cross multiply 1 times 6 divided by 2 would be 3 bags. Okay. Carl buys bales of hay that measure 15 inches by 24 inches by 36 inches, and he needs to buy 250 bales. And he needs to know if they will fit in his barn. So it seems like a pretty natural question. So what is the total volume of hay in cubic feet? So 15 inches by 24 inches by 36 inches, and it has to be in cubic feet. So all these need to be divided by 12. So 1.25 feet, 2 feet, and 36 is 3 feet. So multiply those, and that'll give you volume. 1.25 times 2 times 3, I got 7.5 cubic feet. He also needs 250 bales. So 7.5 cubic feet is for one bale. So times by 250 to get for 250 bales. So 1875 cubic feet. Now this farmer would have to go and measure his barn and make sure he has enough room for the bales. A computer measures 9 inches by 16 inches by 16.5 inches. It requires 1.5 inches of padding on each side to protect it during shipping. What is the volume of the packed box? Okay, 9, 16, and then it was 16.5, so there's the box. These are all inches. So 9, 16, and 16.5. Then it says it requires 1.5 inches of padding on each side. So that means you're going to have to put on 1.5 there, 1.5 there, 1.5 there, 1.5 there, 1.5 there, 1.5 there. So we had to add 1.5 inches on each dimension. So adding 1.5, basically twice per dimension. So that's 3 inches you'd have to add on every time. So plus 3, now it's 12 inches. Plus 3, now it's, and plus 3. So now it's the following dimensions. Now we just need to multiply those to get the volume. So 12 times 19 times 19.5, 4,446 cubic inch. Okay, now we're talking about capacity. Now capacity and volume are basically the same thing, except capacity has to do with liquid. In the American system of measurement called the imperial system, they use these messed up words you may or may not have heard before in your life. You've probably heard of cup, maybe you've heard of pint, you probably haven't heard of quart, and you've probably heard of gallon. Gallon would be like how you get your fuel in America. You'd be $1 per gallon. Okay. I will actually input a picture here that will help you with capacity, and then I'll get you to draw it. Okay, so what you can do is draw a large G, and you can see that it says it takes 4 quarts to make a gallon. So 4 quarts to make a gallon. And then it says it needs 2 pints to make a quart. So in each Q, there's 2 pints. And then it says in each pint, there's 2 cups. So then you'd have to blow this up even bigger and see if you can fit 2 C's in there. So let me just try to make these P's a bit bigger. So in each pint, there's 2 cups. Now to try to give you some context for this, the 2 cups to make the pint would be like basically 2 cups equals a pint. Now, you may or may not have had like the skinny milk carton. Or not the skinny milk carton, but the tiny milk carton. These are like the like a single serving milk carton. You might get like a mini chocolate milk in this. Now the next one is 2 pints equals a quart. So basically 2 of those. So if I could copy and paste, that would be sweet. I don't think I can. Okay, so now I need 2 of these. 2 of those little mini cartons. And that's going to equal the taller but skinny milk carton. This is actually the 1 liter. Now that's like if you get milk, but it's like only for 1 person or for like maybe a few days or a week. So that would be like the 1 liter. Now if we go to the gallon, the gallon would be 4 of these. So 4 of these 1 liters gives you the gallon, roughly. Okay, so you'd have 4 of these skinny cartons to make the gallon, and the gallon is the big jug. So at the grocery store you have like the lid, and then it's really fat, and then it like kind of curls like that. That was kind of bad. But it has a, so there's the jug of milk. So you would need 4 of these to get the big jug. But this picture of the G really does it justice here. So the big gallon, okay, the big gallon, and inside the big gallon is 4 quarts, and inside each quart is two pints, and in each pint is 2 cups, 2 cups. So like to ask how many cups in a gallon, you go 2, 4, 6, 8, 10, 12, 14, 16. There's 16 cups in a gallon. And here's some conversions for the tiny servings, like teaspoon. This would be like in a recipe where you have, a teaspoon of salt. So it's roughly 5 milliliters. The tablespoon is like a big spoonful, 15 mils. And then the cup, which is the smallest serving in the American system, is 250 mils. So this is like a juice box right here. This is like juice box. And small spoon and big spoon. So small spoon, big spoon, juice box. Then up here we have cup, small, like individual milk. 2 of those individual milks make the skinny milk taller, and then 4 of these skinny milk cartons makes the jug. Alright, so you can read example 3 on your own. Let's do question 7 together. So Serena is traveling through the US and her car's gas tank has a capacity of 55 liters. How much is this in American gallons? So on my formula sheet there's a section on the front page that says capacity. So find the one that does liter and gallon. So it says 1 gallon equals 3.8 liters. You have 55 liters. That's X gallons. Cross multiply. So 1 times 55 divided by 3.8. So it's about 14.5 gallons. If gas costs $2.99 per gallon, so basically just times it by that. And remember, anytime you have a rate, which is usually dollars per something, you always times it by the amount that you have. So $2.99 times 14.5. It's like $43, and depending on how you round it, about 35 or 36 cents. So, assuming that she has the same car in London, where gas costs this much per gallon, how much will it cost to fill her tank? Remember that the British gallon is a different size. So I didn't put the British gallon on your formula sheet, so don't worry about that question. And I won't test you on that either. Okay, the box of Jacob's Cube van has these inside dimensions. Calculate the volume of the interior. Okay, so one of the dimensions is 20 feet. The other dimensions is 10 foot 8 inches. So we got to convert that to a singular unit. So let's convert this 8 inches. 8 divided by 12. Okay, I'm getting 0.666666. So that's 10.67 after rounding feet. And then 12 foot 6 inches, that's easy, 12.5 feet. The 6 inches is easy because half of 12. So 12 foot 6 inches is 12.5 feet. Multiply all those together. 20 times 10.67 times 12.5. I got 2,667.5 cubic feet. Alright, last one. 2 storage bins for grain. The first bin's 12 feet 8 inches by 8 feet 9 inches and is filled to a level height of 4 feet 6 inches. If she has to move the grain to a bin with a base measuring 9 feet by 9 feet, what will be the level height of the grain in the second bin? Okay, so first bin, it's 12 foot 8 inches by 8 feet 9 inches and 4 feet 6 inches. So I think we converted this one already. 12.8 inches. That was 12.67. Now 8 feet would be 8 point. Go 9 divided by 12. 9 divided by 12 is 0.75, so 8.75 feet. And 4 foot 6 inches, we did that one already. That's 4.5 feet. 6 inches is half a foot. Multiply all those together. I got like 499. You know what? I'm just going to round up to 500 cubic feet approximately. Then it says what will be the height of the grain in the second bin. So the second one is 9 feet by 9 feet by some unknown height, and it's going to equal approximately 500 cubic feet. So 9 times 9 is 81 times some unknown height is 500 feet. So what we have here basically is some number 81 times some number is 500. So to get this, just do the opposite of times, which is divide.
Please excuse the interruption. All grade 12 AP students.
And 500 divided by 81 is 6 point something. So I'll just say it's approximately, it's like 6.1, so 6.17. So I'll just approximate that to 6 feet. Okay, and you can look at this question and understand what happened. See, this volume only goes up, it only goes up this high, but then it goes up this high on the second bin. That's because this base is smaller than this base. Okay, so for the first bin it's much wider. That's why the volume only goes up like that high. Now for the second bin, because it's much tighter, it's going to go up much higher into the air. And those are some terrible drawings, but I just wanted to give you an idea of why they shoot way up in the air, or the height changes. Okay, thanks for watching, and practice your skills. Do your homework for 3.4 and you're done the unit.